In examples 5 and 6, we're looking at a particular type of function referred to as the Cobb-Douglas production function. In example 5, we're told the function below gives the total number of units produced in thousands using X units of labor and Y units of capital. We want to use Symbolab to find this Cobb-Douglas production function evaluated at X equals 16, Y equals 12. We can do that by entering our function and then evaluating it for X equals 16 and Y equal to 12. We get a result then of 160.553 approximately. And then we can interpret this information by first noting that our, total number of units produced is in thousands, X units of labor is in thousands, but Y units of capital is in millions. So we'll need to multiply this result by 1,000. We'll multiply our X value by 1,000, and our Y value will get multiplied by 1 million, which will allow us to say that when 16,000 units of units of labor and 12 million units of capital are invested, total production will be 160,553 units. We haven't done any calculus in this first example here. We're just looking at a Cobb-Douglas production function and seeing how we interpret that information. Again, telling us about how many units of labor, how many units of capital are invested, and then what that total output is. Now in example 6, we want to look at this idea of marginal analysis applied to those Cobb-Douglas production functions. In part A, we want to find both P sub x and P sub y, the first partial derivatives with respect to x and with respect to y. We could do that in Symbolab, and we would find that P sub x will be equal to 23.4, x to the negative 0.1, y to the 0.2, and P sub y will be 5.2, x, x to the 0.9, y to the negative 0.8. In part B, we're asked to evaluate each of those partial derivative functions at x equals 20, y equals 17. Evaluating the first partial derivative with respect to x would give us 30.5635, and evaluating the first partial derivative with respect to y would give us 35.957. The first thing that we want to do in interpreting these results is just identify which of those values is larger. In this case, P sub y takes on the larger function value for that specific xy pair. And what this means is that if we keep labor fixed at 30,564 units, keep labor fixed at 20,000 units, since that was our x value, while increasing our investment in capital, that will yield a greater increase in production, because while both of these derivative functions take on a positive value, where we get that larger value means a larger increase. Specifically, a larger increase by increasing our y value, meaning that increase in investment in capital will yield a greater increase in production.